Hi, good afternoon, everybody, and welcome to our session, Green Code, Clean Conscience, Tackling AI's Environmental Impact. We will get started in just a couple of minutes, but we're going to give people some time to join just after lunch. So hopefully you've had some time to get some food or something to eat during this webinar. And we'll be starting probably about 2 minutes past 1. So thank you. Hi, welcome to those of you who are just joining. We'll get started in just a minute or so. Hi, I think it's probably time for us to make a start. So, hello, everybody, and welcome. Thank you for spending an hour of your afternoon with us today. My name is Katie Thorne. I'm from the Digital Care Hub, and we're really excited to be having a webinar today talking about AI, the environment, sustainability, and optimization. Just some brief housekeeping for all of you. So this webinar is being recorded. Sometime later on this afternoon, we will put the full recording onto YouTube and send you an email with the link so you can access that. And we will be sharing all slides from today and any links which are mentioned with you as well. So you'll get that email automatically. I'm afraid that all attendees are on mute. We can't see you, so please do say hi in the chat and use the Q&A function to ask any questions from our panel members today. Also, if you would like to, you can enable closed captions at any point and also a transcript, and we will send out a transcript of this recording after the session too. So for our agenda today, we'll do some brief welcome and introduction, sort of setting the scene on this topic. I'm then going to pass to Sudha from Nourish Care to talk from the sort of Nourish experience. Then we will have Mark Russell-Smith talking about AI dimensions and AI-powered optimization. Then we'll have lots and lots of time for sort of a panel Q&A at the end. So do please keep your questions coming. If for any reason at all we can't get to your question, we run out of time, for example, we will also do a follow-up email to any of you. So please don't worry if we miss anything. There'll be lots of time to come back. This has been part of an AI mini-series that we have been running at Digital Care Hub. Do not panic. You don't have to have watched the previous ones for this one to make sense. But those recordings are all available on our YouTube channel at Digital Care Hub. So we've talked about care meets code, defining responsible AI in care. We've also done a session all around whether AI in social care is really helpful or if it's actually just all hype. We had a session talking about technology suppliers and sort of their pledge to develop AI responsibly within the care setting. And then this is the final one in our series. For any of you who aren't familiar with us at Digital Care Hub, we are a not-for-profit community interest company and we provide free support to adult social care providers across England on anything to do with data protection, cybersecurity, tech and AI. And very much sort of working with care providers to really understand what their needs are around sort of technology and answer questions, which has really been the impetus for this session. We have increasingly been getting a lot of questions around the environmental impact of AI, so we thought it'd be good to sort of have a little bit of a conversation around it. We have also been doing a lot of work with Casson Consulting and the Institute of Ethics and AI at Oxford University, looking at the responsible use of AI more broadly. This includes co-production across people with lived experience, care workers, care providers, commissioners, and technology industries. So if you want more information about any of that, we will be sharing links in the chat. So, how does AI impact the environment? I think it's fair to say, we'll talk about it a little throughout the session, that there's still fairly limited evidence nationally in terms of the environmental impact of AI in social care specifically. But there are some quite large sort of numbers that are coming out and some kind of key headlines I thought we might want to talk about. So, digital technologies, not just AI, have been said to contribute nearly 3 times the amount to climate emissions as flying, which I think is a really astonishing fact. We all tend to think the aviation industry is one of the biggest polluters. And in terms of AI specifically, some of the areas which really cause the most issues are the data centers, which have huge amounts of energy usage. They also have electronic waste, such as mercury and lead, which can go out into the environment. Water usage is quite intensive as well. And also, in order to develop AI, there's a lot of microchips which need to be used for that. As with many other digital technologies, and rare earth elements are often mined in very unsustainable ways, which can also impact the environment. So, those are some of the ways that we're thinking about AI and sort of how it can impact globally. But in terms of what it means specifically for us in social care, we're hoping to be a little bit less on the global scale and a little bit more practical. I think things to bear in mind is that there is quite a lot of research that a request made through ChatGPT consumes 10 times the amount of electricity as a Google search. So, small things that we can be doing as individuals in terms of thinking about the environment is to use a Google search if we need a Google search. Other search engines do exist, obviously, your preferred search engine, and maybe use ChatGPT more and other sort of large language model, generative AI for more specific purposes, which you couldn't do a Google search for. And I just wanted to put in the stat as well about Ireland from the UN Environmental Programme, which I think is quite astonishing. So in Ireland, the rise of AI could see data centres account for nearly 35% of the country's energy usage by 2026, which I appreciate. Ireland has a much smaller population than we do, but it's still a huge amount of energy to be using. I'm not going to go through all of these use cases, but these are some of the ones we'll send out to you following this session. There are also quite a lot of benefit cases and use cases of how artificial intelligence is being used to reduce carbon emissions as well. Specifically looking at things like smart cities, using smart monitors in people's homes to monitor energy usage and reduce energy usage, and AI optimization for domiciliary care, which Mark is going to be talking about later on today. But just wanted to say we will be sending these resources to you afterwards. And with that, I think I will stop my introduction. I will stop screen sharing at the moment. And I will pass over to Sudha. And Sudha, if you'd be happy to sort of introduce yourself and go from there.
Thank you, Katie. And I'll actually, if you don't mind, I'll share my screen because I just made a change in my plan. Sorry. Will you let me know if you can see my screen, please?
I can see it, but it's not in presentation mode.
Okay. Is that better?
Oh, it's disappeared for me now.
Apologies.
It's okay.
Zoom noob, everyone.
There we go.
Yes. Okay. Hi, everyone. My name is Sudha Ragmi, and thank you, Katie, for this opportunity. I'm really looking forward to this conversation. My name is Sudha Ragmi. I'm the Director of Data and AI at Nourish Care, and I've been sort of building AI solutions. I'm a data scientist by training, building data AI solutions, and sort of working with lots of other organizations in different sectors to think about what to build, to sort of advise them on the right sort of technical processes to build for a long time. And at Nourish, my focus is sort of taking our existing data and analytics capabilities, our insights and analytics products, and enhancing them and scaling them, and then also introducing more sort of AI-led solutions. So I think about AI all day, every day. Looking forward to this conversation today. As we think about AI, and thank you, Katie, for sort of sharing some of the stats, but I wanted to share this a little bit just to give a view of how widespread the use of AI and how widespread the hype of AI is, right? Obviously, we in the care sector talk about AI day in day out because it's we're seeing it as an opportunity for us to be more effective and more efficient in delivering care, rightfully so. But globally and across lots of sectors, obviously AI has a huge potential. And then you might have seen some of these statistics. There's studies that talk about almost 16 trillion of global GDP uplift by 2030. So I give you this number to just show the context, of the impact AI can have overall in our sort of day-to-day lives, but also in our economies. On the right hand side, and there have been a few conflicting studies now, but there was a study that was done by MIT that talked about actually 95% of pilots fail, and this was done based on executives, and then and that's on 40 billion annual investment. The study did tend to sort of index more heavily on the U.S. And you'll see why there's such massive numbers. But you'll see that, and this is very interesting, right? Everyone's experimenting on AI, everyone's on the AI hype train, without fully understanding what we want to do with AI. And I think sometimes that is the challenge of getting value out of AI. So a lot of folks might be sort of trying to use AI for AI's sake. You give a really good example, Katie, for example, using AI to replace Google. Let's not do that, right? Where does it make sense versus where it doesn't? Maybe if you're in a deep research mode and you want to figure out a really sort of, instead of having to do 5, 8 Google searches, going deep into lots of sources, try to analyze that information, perhaps you use AI to help you sort of drive that process faster, but replacing sort of everyday Google search activities with AI is probably not the solution. And I think that's what we're seeing people do on a day-to-day lives, but also in a more in enterprises and in companies. And I think that's why we're seeing these kinds of numbers. And then that's why there's always this hype about, oh, AI is going to take away all our jobs. Oh, no, AI is horrible. Oh, no, AI doesn't really work. And I think a lot of the hype has been created by companies that have agenda, but also by people not knowing how to use AI. And so I'll use that so as a context today for some of the conversation. Uh, this again is meant to again help us take a sort of take a step back and just look at the scale of AI, right? On the left hand side, you'll see rapid pace of AI innovations. Just this last week, I heard of two releases. I think last night, OpenAI came up with a chat GPT 5.1 release, and I've already started using it. Claude came out with papers that tells us how we should use AI, and perhaps giving it a lot of context isn't necessarily the right thing to do. So every day there's sort of research and there's innovation coming out of these massive organizations and massive labs. And to be honest, that's probably what's driving all of these scary numbers in terms of energy consumption. But then on the right-hand side, we also see that there's sort of value that companies are leveraging AI. So companies are using AI models, Gen AI models, large language models in particular, that using it to drive scale, drive efficiency. And I think that's where we should really be focusing the conversation in the care sector. Having said that, I want to talk about how we at Nourish think about sort of AI in the care sector. And then this is almost sort of showcasing our principles about AI. So we love talking about this thing called triple aim for social care. So it is a concept that we borrowed and modified from the US healthcare, where they talk about triple aim for healthcare quite a bit. And for us, this intersection of care quality, personal outcomes, and care operations is where good care really effectively lies. So as you'll see on the right side of this, I talk about sort of, the three pillars of good care and triple aim. Care quality, right? Making sure that you can use AI, you can use data and AI really effectively to drive sort of quality of care outcomes, positive clinical and care outcomes for people who draw on care. Personal outcomes, again, this is a sector that needs to be super people-centered. So how do you make sure that the experiences of people who are drawing on care are personalized still, and AI doesn't take away that sense of personalization? Yeah, AI just doesn't convert people into zeros and ones in binary code. That's super important to keep in mind as well. And then care operations, and this is probably where when we talk about environmental impact and energy efficiency of AI, perhaps this is probably where we can talk, this is probably the pillar that it most relates to. How do you make sure that care operations can be more efficient for care providers while maintaining or improving care quality, right? And so based on that, keeping these pillars in mind is how Nourish came to sort of our backlog of use cases, and then we sort of refine that further to come up with use cases that we think would drive the highest value to our customers, have the least clinical safety sort of risks, and also allow us to build faster and in a cheaper, sustainable way. Because again, there is that cost implication of AI as well, which, yes, there's an energy cost implication, but then because of that and because of lots of other reasons, AI can be really costly to implement. So that's how we sort of view AI and then sort of our implementation plan at Nourish. I'm not going to be sharing very specific use cases and very specific product roadmap that we're building today, but I just wanted to give you a little bit of that context as we sort of have this conversation. Ooh, I didn't. So as we think about AI and environmental impact, I think it's really important to think about sort of the considerations that you might have. When we talk about AI, a lot of conversation has been sort of focused on generative AI, and rightfully so, because generative AI and ChatGPT, when 3.5 came out at the end of 2022, that's where a lot of people started experiencing AI. It made AI very accessible to people, right? But AI as a field has been existent since I want to say, 1950s is when I think there was a Dartmouth paper that was released. And even before that, I mean, we talk about Enigma and then how sort of cryptography and AI was sort of used as some of the early examples of AI being used to help us sort of win World War II. Alan Turing has been written about, when thinking machines. That paper is considered a seminal paper of AI. So this whole idea of neural networks, artificial intelligence, machine learning, pattern recognition has existed for a long time. I think what and those sort of AI techniques can be accessed in a much more energy efficient manner. And so when we talk about AI, I think it's also really important to talk about what kind of AI are we talking about. And typically, let's, throughout this conversation, we're going to be talking about generative AI quite a bit. And so as we really talk about generative AI, there's perhaps two ways to view consumption, energy consumption, right? The first one is, well, actually, energy required to train these models, these foundational models. So what, OpenAI, what Microsoft, what Anthropic, what DeepSeek, and all these companies, large companies, are doing when they're building these models en masse to then release it, right? That training effort is massive. It requires huge amounts of sort of effort. It requires huge amount of data, and that's why we talk about AIs being effectively trained on the whole internet. And then because of that, it requires huge amount of compute power, and that's where you need big data centers to power the training of those models, and that's before those models are used at all, right? This is almost this. I would almost think about this as actually a car manufacturer building car in a factory, that consumption required before that car even hits the road. And then when you as a user access the AI through lots of ways, whether that's through a product that might already have AI embedded into it, like Google, which sometimes has AI embedded into it, or through actually LLMs models, directly through these providers to build something that you're trying to build out, then there's that inference cost, and it's called inference cost because it's and the cost is AI needs to, there needs to be some calculation that happens every time you ask an AI question and you get an answer, a response, right? It might not always be a question and answer, but effectively that. And that is also a big sort of recurring cost. So I think it's important for us to separate the two, because the first cost we can't really control. I mean, yes, we can control by through the whole as sort of users of AI and this whole notion of demand and supply, but fundamentally we don't have as much direct control. But as users of AI, the sort of cost that is the cost, the energy consumption that's used when we use AI is within our control. And so really thinking about what are you using AI for becomes super important. So what are you doing with AI? Are you using AI just for AI's sake, just to say I'm using AI? Are you using to summarize everything? Are you using to create first drafts of really awful sort of essays that then you toss out because you realize the sort of language doesn't look right? Or are you using it to sort of add value and to drive value? I think it's really important to think about use cases. I love talking about use cases in AI because otherwise you're just experimenting. Otherwise you're just playing with AI and learning, which is still good, right? But I think it's about time now that we stop talking about experimentation and playing around with AI and really think about what are the big value drivers of AI and how do we go towards using AI for that to get that value, knowing the sort of cost and cost benefit analysis of, well, actually recognizing there will be energy and environmental implications, but we're doing it responsibly. And then the last part is where it gets really interesting. I mean, we always in media we always talk about and we always hear about these stories of, well, actually, AI has AI is taking electricity away from farmers in California, perhaps. Those are news stories we hear, right? But then there's also stories and there's also cases of where AI can help in energy efficiency. And these cases have sort of written out that are very care home specific, and I'm happy to sort of discuss some of them. So when we talk about occupancy management, really understanding in your sort of care home, if you think about sort of care home scenario, who are your residents and where are they, and managing occupancy in different wings, knowing that, deciding on making sort of heating and cooling decisions based on where where your residents are. That has a huge impact on sort of AI sorry, that has a huge impact on environment, and visibility of that data, insights, and AI can really allow you to do that. For example, at Nourish, we have this insights board called Occupancy Board, and we're about to include information on where, so adding more hierarchy. So not just talking about how is a care home occupied and what does that occupancy look like across time, but actually allowing you to have visibility into where within that care home are people occupied and how does that change with seasonality. Are you putting people in, in the summer regions? Are you putting people in perhaps part of the building that gets more sunshine naturally, so doesn't have as much heating costs, versus in winter, are you, yeah, are you sort of managing costs and managing energy consumptions by looking at where people are, a concerted group of people are occupying care homes? That can be quite interesting, and we're allowing that capability through this concept of wings and sort of locations within occupancy. And I think having that kind of visibility is the first step, right? The second type of example around sort of, and this is sort of relatively new, but this concept of AI-driven auditing and how that plays into predictive maintenance. So in non-care sector, we talk about predictive maintenance quite a bit, especially in really high energy consuming sectors like manufacturing. So when you've got, for example, an oil rig, or a big manufacturing plant, being able to identify where your machinery is not performing as well as it should has a huge impact, right? Because decreasing sort of health of machinery has an impact in two folds. One, by increasing energy consumption as that quality of machinery decreases, which means the output is reduced, or by actually stopping together, which it can have massive impact. In care sector, it's something similar. We don't have massive machineries, but we still have all these HVAC systems, like I talked about, refrigeration systems. Some of our care homes now have sort of smart machineries. So they're all digitally powered machineries. And so having a view of their health and their state by enabling more AI driven and data driven auditing really helps. So it's two front. One, actually collecting data and more easily in terms of actually auditing effort, which is really difficult to do right now. And then the second one is once you have that data, really trying to understand, well, actually, what are my equipments that might need more proactive maintenance cycles, so that you're actually sort of solving that problem without letting it go on for a long time. So that can help. The third one is sort of smarter monitoring, very similar, actually being very proactive about energy usage in care homes and monitoring that across time and sort of optimizing based on energy consumptions and loads, etc. can be really helpful. And the last one, I know Mark, you're expert on this topic, but also this is a topic that we're looking at quite a lot. How do you make care homes run care home operations run smarter? So this idea of, well, a care home is made up of lots of staffs, or home care sort of group is made of lots of staff. How do you make sure that you're helping them get to places faster? How do you make sure that when you're scheduling sort of appointments, when you're scheduling their shifts, for example, you're doing it in a way that can optimize for energy efficiency by reducing driving times, by reducing small breaks between shifts and things like that. So those are the ways that AI can really help in energy efficiency. I think it's really important to think about, yes, the sort of cost of AI, but also the opportunities that AI really gives. And I mean, it's interesting. Sometimes it can seem a bit dismissive, but I don't mean for it to be so. But AI is just a tool, right? How you use AI is the bit that really matters, and then how we use AI is a decision that we all should be making and thinking critically about every day. That's all from my point of view. Katie, over to you.
Thank you so much. That was absolutely fascinating. I'm still completely mind blown, to be honest, about the figure about 95% of pilots failing, which I assumed it was going to be high, but that feels incredibly high, to be honest with
I'll send you
you.
that paper. Yes.
Yeah, I actually just thought as well, because the occupancy management AI usage, I think, is something which is quite interesting. And in terms of obviously, there's the win in terms of you can be more proactive about how you're using your heating and your lighting and all of that sort of thing. And so that's great from an energy usage perspective. But obviously, got issues with cost of living. Bills are very, very high. So actually, as well, from a running cost perspective for residential care settings, like there are benefits there as well, which is nice to see a win-win in these things.
Yeah. Lovely. Thanks for pointing that out. Makes sense.
Brilliant. Tell you what, we will pass to Mark now because that was a great segue to go into fostering and scheduling optimization. Thank you. And then we will come back at the end for some more questions, if that's right. Mark. Oh, hang on, you're on mute,
I
Mark.
am unmuted now, so yes. Shall I share my own slides or?
If you wouldn't mind, that's great. If not, I can grab
Yes.
those up for you.
Yes, I have here, so. How do you see that? Do you see just one slide or do you see my whole screen?
I can see the whole screen. If you click into presentation mode, it should come up.
Yes. Okay.
Yeah, perfect. There we go.
Is that fine? Yeah, I think it's great to have such to follow Sudha. That was a really great presentation. Thank you, an overview of AI. And now this is a little bit about what we do at AI Dimension. So we do AI-powered optimization, and you can refer it as route or schedule optimization, but it's actually much more profound than that as well. So I'll explain about that as we go through. So yeah, about AI, there's all of the attention seems to be on generative AI, Copilot, ChatGPT, and ambient voice even, and things like that. And then wondering what the actual application will be and what will be the impact. And then these things are consuming vast amounts of power. I find it interesting that the data centers are measured in terms of how many gigawatts they consume. Um, I'm based in Finland, not far from the Arctic Circle, so it's snowing just outside my window, and electricity is fairly cheap in Finland, and that seems to drive where companies like Google build their data centers. They need cheap electricity, and there's going to be a big Google data center built just down the road from where I am in Finland. So that's interesting to see. Another application people know about from AI is predictive analytics, and this is about spotting patterns in past data and then predicting what might happen in the future based on past trends. And one good example of this is predicting falls. But a little known type of AI, which is what we do, is called prescriptive analytics. And this is about answering the question of what to do to achieve the objectives that you're after, or how to do things differently. They're not just about looking for patterns in past data and copying that into the future, but really looking at how to do things differently. So that's what we do. And our roots are in transport logistics optimization. So we've been doing optimization now for about 20 years. Um, and my history a little bit, I found one of my old university papers from 1996 where we had done a project to build a neural network for pattern and image recognition or classification. So that was from 1996. But in AI Dimension, yeah, we've been doing optimization for close to 20 years. And in transport logistics, our largest customers optimize close to 400,000 shipments a day. And all these services like next day delivery, which we take for granted now, just wouldn't exist without really advanced optimization like we do. And we worked with home care since 2011 in Finland to start with, and now we work in several countries, including the UK. So we started working in Finland back in 2011 because that's when pressure started to be felt on the home care system. And I would say a big reason for that is that workers are paid for shifts. And when workers are paid for shifts, you really have to take care of how many workers you are using and to make sure the workforce is utilized well. It's expensive to keep adding workers when they're paid for 7.5-hour shifts. So I would say the issues in home care in Finland, the fundamental problems are still the same everywhere, I would say. In England, home care workers are often paid for contact time only. But what we're starting to see is no matter how the workers are paid, whether they're paid for shifts or paid for visits, it really helps to try and utilize the workforce well and minimize the gaps and minimize the traveling. So what we see, home care is a logistics problem. And since we started, we've now worked with around a third of the domiciliary care workforce in Finland. We've done over 100 home care projects. And it's, again, much more than just automated route planning. It's more transformational than that. So one of the key problems behind logistics problems like home care or community care is the extreme complexity. So you quite quickly end up with more possible permutations than there are atoms in the known universe. And this makes it extremely challenging for frontline planners to create efficient and effective plans. And then it's also difficult for policymakers and senior managers to identify possible improvements to the system. And it's also difficult for people to understand how much better they could be doing, because they do the best they can with the tools that they have, but they're just not aware of how much better things can be when there are an almost infinite number of possibilities for how things could have been organized. So with this, the typical planning processes in domiciliary community care involve allocating tasks to workers. So I think we're familiar with the typical types of planning screens where you have the unallocated visits at the top, and you have a manual drag and drop interface where you can drag the visits onto the workers. But whilst this is being done, tasks are being allocated to often all of the workers you have without any understanding of how many workers are actually needed. And it's difficult to identify bottlenecks or things which are maybe even structural issues which are limiting capacity, and to identify ways to improve the system. But the way we work is that with optimization is we sort of turn it on its head a bit, and we look at how many people are needed for the tasks, first of all. And then we can optimize the optimize the workforce, ensure the workforce is well planned, find improvements to improve the quality of care and stability of planning, and also improve the metrics like how well the workforce is used and even mileage. So Gartner have got this analytic value calculator, which describes the complexity and value of different types of analytics. And basic analytics, you have descriptive and diagnostic analytics, which just describe, it's the basic data on what happened in the past. And then predictive analytics, which looks for patterns in that past data and projects that forward to predict what might happen in the future. But it doesn't tell you what to change if you want to do things differently. But what we do in AR Dimension is prescriptive analytics, which is about identifying the changes you need to make to achieve your strategic goals. And it's a lot to do with the workforce and budgets nowadays in the environments that we're in. So basically, with optimization, we can optimize on different levels, and you can think of these as depending on the sort of planning horizon we can refer to it as. These can be strategic optimization, tactical, or operational optimization. And the strategic and tactical optimization, it's an approach which has been borrowed from the logistics world, and it's about what if scenario modeling. So we take data from across the system. It can be from a single home care or community care team, or from across multiple organizations, and we can analyze, visualize how things are working at the moment, then model how things could be done differently, and what kind of changes would have what impacts on things like the number of workers you would need, and the traveling, and even metrics to do with the quality of care. And this is really good for providing engagement between the different stakeholders and transparency and even co-production, because when we look at the different scenarios, the different stakeholders can be involved. They can see how certain changes would impact their own working lives, and also the working lives of others. And for example, we've worked a lot with integrated teams over the last 4 years or so in Finland, and some other in the Benelux countries as well. And this has been to do with redesigning the share of responsibility in integrated teams, and looking at how that would impact people's scheduling and routing, and the number of people you'd actually need, and the skill mix. And then, of course, there's operational planning, which is the day-to-day planning within a home care or community care organization, or even in a logistics company. I mentioned our roots are in transport logistics, but of course we know that delivering care is quite different to delivering a parcel, but we've worked with care since 2011, and a lot of work has been done to adapt the system for the needs of delivering care. So a little bit about strategic optimization. When we started working in the UK, we knew that home care wasn't working as well as it could be. There are some structural issues in the UK. So we took data from across the system and then looked at how things were working and then show how things could work. And we know that from the Home Care Association that home care workers travel 4 million miles a day. And that's equivalent to the moon and back 8 times a day, which it's quite an absurd amount of traveling, actually, if you think about it. So, and if you think about the amount of fuel that's being consumed and carbon that's being emitted, it's quite vast. So that's 1.5 billion miles per year. And this is how they do it. This is how it's being done. So this is an example of the morning routes of 6 home care providers in Bristol. The map background has been blurred to anonymize it a bit, and the routes are shown as straight lines as the crow flies, just for clarity. But the interesting thing is that traveling is not it's not the main problem. Traveling is important, but it needs to be proportionate. And too much traveling is obviously a problem. We have too much traveling in the UK at the moment. So I think it's 2.7 miles per visit. And too little traveling is also a problem. And here's an image which was created using generative AI, by the way. And for example, if you take it to the extreme and try and reduce traveling, you could have one worker for every service user waiting outside their front door for when they needed a visit, and you wouldn't need any traveling at all, because home care workers are usually only paid for traveling between visits and not for traveling to and from home. So you could eliminate traveling altogether, paid traveling, but of course it would need a massive number of workers. And interestingly, in the UK, there's a massive amount of traveling, that 1.5 billion miles a year, but we also have a lot of care workers. So the ratio of care workers to service users is around 1.5 to 1, I think, around 1.5 service users for every worker. So we have a lot of workers and also a lot of traveling. So interesting combination. So looking at this a bit further, simplistic approaches like geographic clustering sound good on the surface, and they aim to minimize travel. But when you cluster visits geographically, you also end up clustering visits in time. And this leads to poor work or load distribution and poor workforce utilization. And then taken to the extreme, as I just described, so you could have one worker for every client and you wouldn't need any traveling at all. So you need a much more nuanced approach, and you need to know when to travel, or when not to travel, when to stay put, and when to wait. And this also starts to feedback and inform care plans and co-production ultimately. So this is where a lot of work has gone into in Finland, for example, to make shift to pay sustainable. And some truisms, some logical truths. So when you start to try and utilize the workforce better and have better filled work shifts, you end up with more travel legs between visits, and workers need to cover a wider area. So the planning becomes more challenging. But then optimization can help manage this. And also traveling takes time. Travel time can't be cut, only service time can be. So an interesting thing we see is that when planning is done back to back without any travel time given between visits, or even when you use fixed blocks of travel time, 5 minutes, for example, planners can lose sight of the map type of view and then traveling can really get out of hand. I mentioned that traveling is not the most important thing, but perhaps workforce utilization. This is an example of workforce utilization in the UK. We've done this in several places in the UK, and this, I believe, is fairly typical. The bottom line shows how many visits are being planned across the day. There's a bit of a peak in the morning, and then a lull here in the midday, and then lower load in the afternoon period. And the dark blue shows how much time is needed for traveling. And the gap here is just unused gaps in care workers' schedules. And this time is not only unused, it's not paid usually either. So this contributes to poor workforce satisfaction. So one message from this is that paying for travel time won't solve the pay issues in the home care sector. And interestingly, we have works in the Netherlands just after 0-hour contracts were not quite banned, but severely limited, and replaced with guaranteed hours contracts. And it didn't have the intended results over there because it didn't change the fundamental working conditions for home care workers. So that's some learnings from abroad, which I think are important to bring to the UK. I think the answer is really ultimately to work towards shift pay for workers, or to start with, to treat the workers as if they're paid for shifts. So going back to that image, how care workers are traveling at the moment. So as you know, many local authorities commission a huge number of home care providers in an uncoordinated way. We took this data from 6 providers, and this is how they were traveling. And this is how the same care packages could have been delivered. And mileage here is reduced by 65%, and we need 35% fewer care workers each day. And the amount of work stays the same. The amount of contact time has stayed the same. It's just organized into better, more compact, better filled shifts. And that was based on around 50% of care packages in the area. We've done this elsewhere with access to 100% of care packages and reduced mileage close to 85%, which would actually bring the UK mileage figures closer to the benchmarks we see in international cases, around 1 kilometre or less per visit. And of course, this would have a significant impact on CO2 emissions, but also on the workforce and capacity issues. So you have fewer gaps in workers' schedules and better pay as a result. And this would start to pave the way for shift-based pay. And a lot of work has been done in Finland to make shift pay sustainable, and about doing this strategic optimization modeling to identify the types of changes which are needed to unlock that kind of efficiency and quality of care which is needed for that. And again, it's not just about traveling, it's about utilizing the workforce well. And one key thing is reviewing which tasks are done when, and only doing the essentials during the peak times, and shifting non-critical tasks to other times of day and coming back later, perhaps. And all of this is not about telling people what to do, but it's about being able to model the alternatives and see what the impact would be, and then making informed decisions and helping the people who make those decisions and all the stakeholders to understand what the trade-offs are and what the alternatives could be. Here's another example. This is from a fairly current case. It shows the example of, I mentioned this sort of relationship between the number of workers you have working each day, or the number of shifts, and the mileage. And the left is the baseline. It's figures from the provider's current operations. and it shows number of shifts each day, 116 shifts each day, morning and evening in total, and the mileage per week. So that's how things are done at the moment. If we optimize keeping the number of shifts the same, the thing we can optimize is mileage. We can reduce mileage by a little over half in this example, keeping the same number of shifts. But we can also create better filled shifts. So in this case, we can reduce the number of shifts needed by a bit over 20%, but the mileage is reduced, but not quite as much as if we use more shifts. So this is the kind of trade-off. But normally it's preferred to try to fill people's schedules better. And where we work in Finland and also some other countries, the unions are usually involved in any kind of change. And the Finnish Nurses Union have written 2 articles about us because they've seen that although people might end up doing more work, they're less rushed because the workloads are better distributed, and those systemic issues which cause them problems have been addressed by looking into those with strategic optimization. So this is how it's more than just optimizing routes and schedules, but about looking at the whole system. I think this is almost my last slide, but this is about integrated teams and workforce redesign. So I would say in Finland, they're a little bit further down the integration road than in England. So many of the teams we work with are integrated in some way, or at least have a mix of different professions and skill levels. In fact, when I talk to Finnish colleagues, they don't always recognize it because it's business as usual, interestingly. But what we see in integrated teams is they're often integrated in name, but the different professions are still planned separately. So what we've been doing, and quite a lot over the last 4 years, is modeling different scenarios to help with workforce redesign. So we can look at the share of responsibility in integrated teams and show what would happen if people would be trained to do different types of tasks and to change the share of responsibility in those integrated teams, and then show how that would impact the need for traveling and the number of workers. And this is an example from a case where integrated teams were in use, and the sort of model team had 11 care assistants plus 6 registered nurses, but the planning was not integrated. It was separated for those different functions. So we looked at the mix of staff and skills, and in the end, the number of registered nurses was halved from 6 down to 3 in each team. And the registered nurses still needed to handle some kind of unplanned urgent response type events. So their utilization was limited to somewhere around 50% still. So this, of course, has real world savings. And I can't see my clock. I don't know how long I've been, but I think I'll stop there about to leave some time for questions.
Great, Mark, thank you so much. It is absolutely fascinating. I've seen some of these stats before. As somebody who personally hates to drive, I'm always horrified by the number of millions of miles that care workers are having to do every year. And what I think's quite interesting about sort of what you're talking about in terms of workforce optimization, if we think in England about sort of the workforce statistics and sort of the workforce shortages that we have, the most recent report from Skills of Care is we're short 131,000 people working in adult social care. So actually what we can be doing to make sure we're using the workforce that we have in ways which is not just better for efficiency for the system, but also can improve their working conditions, be better for their mental health, I think is really, really positive. One of the questions I actually had sort of listening to that is, I have to say, I am also not as familiar with prescriptive analytics as opposed to predictive analytics. Why is it, do you think, that prescriptive analytics is sort of like less commonly used or commonly known?
Yeah, well, I think it's just that most people wouldn't have any needs for prescriptive or come across prescriptive analytics in their daily lives. So, of course, I should have mentioned now people are really familiar with generative AI. People are
Hmm.
using it for generating pictures and text, but in normal life, people don't use prescriptive analytics. It's widely used in logistics. So if
Mm.
Amazon are going to build a new warehouse somewhere, they won't just build it and see what happens, or build a small scale version like a shed somewhere and see what happens. They'll model different scenarios and then make a decision based on that. And also, for example, I know next day delivery is a common thing now, but previously, if logistics companies were delivering in 2 or 3 days and they wanted to deliver in one day, they would have modeled how they could have done that and then understood the different options and what it would have cost and what they would have needed to do those things, and then made a decision. And once they'd made a decision, they would flick the switch and start to do that. They would know exactly what to do because they had modeled it.
Mm. Yeah, I think basically what I'm learning is I need to look more to other sectors as well and sort of understand sort of what we
Mm,
can bring in. Sudha, did you want
yeah.
to come in there? Sorry.
Yeah. So that's exactly what I was going to say, because I mean, in supply chain sort of sectors across different industries, supply chain as a function, it's a widely used approach. I think it's also a different type of modeling approach, like Mark said.
Mm.
It comes more from sort of mathematics and engineering rather than sort of computer science and statistics, where traditionally some of the other analytics techniques and data science and machine learning have come from. That's why it's all related in terms of decision and how decision gets made in a more data-driven way. But under the hood, they use slightly different techniques. So it's also tougher to find specialists in prescriptive analytics sometimes. So I
Yeah.
think that's probably it. In care sectors, I think it makes sense when you're sort of scaling to really large problems to use prescriptive analytics. And then sometimes day-to-day care providers don't think about sort of the whole ecosystem as a whole. And so it's sometimes difficult to translate that problem into an optimization type of problem.
Sure.
Mm.
Yeah, no, I can see
And
that.
it's not just about pressing a button and getting a result. It's a bit more transformative than that. So, for example, before we implement optimization or take it into operational use in a provider, we will do some level of um, looking at how they can do things differently using optimization. I had an interesting conversation with somebody a couple of days ago, and we're talking about the manual planning process. And when you're doing typical manual planning or using the auto allocate functions in some kind of system as to help you, it's very laborious and time consuming. You have time to make one plan and then tweak it a little bit until you're happy. But with optimization, you have all this power. You can create a scenario, a set of results, and then see how it looks. You can make some changes to the care plans or the structure of your teams or the patches of your teams, and then update the results quickly, and then you can quickly iterate on that, and then go a bit further than just optimizing routes and schedule. And that's why I showed as well the example of optimizing just for mileage, or also optimizing the workforce
Mm.
and the systems.
Yeah. Okay. And something, you had in your presentation, which I quite like, 'cause it's something we talk about a lot as well, is like not using AI for AI's sake. And I was just wondering if you had any tips, either of you, for, if anybody's listening today, in terms of how can they think through, or what approach should they take to making sure AI is being used for, a specific outcome, as opposed to just for its own sake. Do you have any tips?
For me, when we look at organizationally, for example, I mean, day-to-day personal usage of AI is based on whatever tool you find the most convenient. But when I look at an organization and I say, well, when I think about Nourish, how do we build Nourish AI for Nourish customers, or how do we internally at Nourish use customers? I typically look at what are we trying to do? What do we do in the day-to-day, and how can automation or more data-driven decision making help? And then after that, and that's where I call use cases, right? Where can use cases be helpful? And then from there, then I think about, okay, what's the most valuable technical approach to it? Is it generative AI and actually getting sort of, applying some kind of LLM to it? Is it actually understanding patterns? So I actually need to build that model myself, more machine learning. Or is it at the first case, actually just being able to understand root cause? And typically you'll see, I mean, I love, Mark, that you showed that Gartner graph that, we all know and love. But in the first instances, a lot of people don't even understand what the root problems are before trying to go and optimize for it, or go and try to predict for it. And that, while that automation and jumping through the hoops is possible, I don't think it's the right thing to do if you're trying to fundamentally change how you do business. So being able to start a little bit slower, trying to understand the problem, for example, actually understanding in false prediction, understanding, well, do you have a false problem? What is your baseline, right? Are different organizations, are the false rates different in different sectors, different organizations, different sort of cohorts, and then going from it and trying to understand what are the relationships are driving that, then predicting it, and then looking at, well, actually, these are the interventions that typically seem to work. So let's prescribe these types of interventions to optimize for fall rates in these different scenarios. So you can go in that journey. Sometimes it's okay to sort of hoop past some of those stages, but I would recommend for a lot of use cases really thinking about how do I start to understand whether or not I have a problem is important before you try to find the right solution.
Thank you. I think that's, unfortunately, we're out of time, but I think that is a really nice note to sort of end on in terms of being more specific and, thinking through how we're using AI. As I've mentioned to people before, we will send out the slides and the recording after the session. Sudha, Mark, are you okay with people getting in touch if they had any follow-up questions with you?
Yes, happy for my email address to be shared, or people should feel free to reach out on LinkedIn as well.
Really
Yes, I'm happy for people to contact me as well.
wonderful. Thank you both so much, and really, really appreciate you both taking the time today. So thank you for being here, and thank you everybody for joining us as well. Hope it's been useful.
Thank you, everyone. Thank you, Katie. Enjoyed it. And thank you, Mark. Super,
Thank you.
super.
Thank you, everybody.